Data flow in SwiftUI is controlled by property wrappers. A property wrapper is a simple, generic class or struct that has some logic that gets triggered whenever the value of the property gets modified. In SwiftUI, we have state, binding, observed object, published, and environment object that all play a role in managing the state and presentation of your views. In this video, we'll take a very simple starter project and work our way through each of the different property wrappers so that by the end, you'll hopefully have a clear understanding of when and how to use each of them in your own SwiftUI projects. If this is what you're interested in, then keep watching. Before we start, I should mention that there are many good written resources on this subject, not the least of which are these ones from Sagar Unagar, Majid, Saroon, and Paul Hudson. I'll leave a link to these in the notes below. If you learn better from reading blog posts, then these might be useful to you, and I encourage you to check them out even if you stay with me through this whole tutorial. What we're going to do is work our way through this sample project, and a link to it is in the notes below. The starter project has all of the UI in place, and you may take issue with my design layout, but that's not the purpose of this video. Currently, none of the objects with actions are wired up. We have two buttons and a future navigation link in this content view where we will start. When we tap the New Number button, we want to generate a new number and update the lucky number field. As we move through this process, we'll learn how to essentially pass values onto different views, whether that be in a modal sheet presentation or a navigation stack, and be able to update the information on any view and see that it is updated on all other views. We'll be starting slowly by using the state and binding property wrappers to pass only a single value, the lucky number integer. We'll then introduce an observable object and pass it around using the observed object and publish property wrappers, and finally explore the use of the environment object property wrapper. So let's get started. This will currently display the value of the variable number using text interpolation in the text view. If I change the value of the number, the view updates when I force a refresh. I want SwiftUI to be able to do that by choosing a random number from 1 to 10 by the click of a button, and then have it change the value of the number. Seems easy, right? So let's, within the action of this button, set self.number to be an integer between 1 and 10. We get an error immediately. Cannot assign to property. Self is immutable. SwiftUIs are structs, which mean they are immutable by default. They are value types. If this were our own code, we could mark methods using the mutating property to tell Swift that they'll change values, but we can't do that in SwiftUI because it uses a computed property. What we have to do is wrap our variable in a property wrapper that will store the value in a special internal memory outside of the view struct. This is the state property wrapper. Only the related view can access it, and as soon as the value of the state property changes, SwiftUI rebuilds the view to respect the changed in value. For this reason, whenever we use the state property wrapper, we should also designate it as private, since no other view should be able to access it. We'll update our canvas and go into preview mode, and we see that the button now generates the number and forces an update of our view. In SwiftUI, we always use the state variables to trigger some kind of action, like showing a modal view, and in SwiftUI, this is done by using the structs sheet method. This means that the isPresented argument must be bound to some variable that can change its state, so we need a state variable for that. Let's create a state Boolean variable called presentModal and initialize it as false. With the state variable defined, we can complete our sheet method by binding isPresented to presentModal and presenting a simple text view with the text Hello World. Now all we need is some way to make it true. Well, we have a button for that, so all we have to do is either set it to true or toggle it And since it's decorated with the state property wrapper, we can do that. Self.presentModal equals true. Refreshing our canvas and trying this out, we see that the modal sheet is presented as expected. Now something funny is going on here. The modal presents itself when presentModal is set to true, but when do we ever set it back to false? We don't specifically, but the modal view does it in the background. Anytime you dismiss a sheet, the Boolean value that causes the presentation gets set back to false when it's dismissed. And since this is being done outside of the view itself, you might be confused because didn't I say that no other view can access it? Well, remember when we first implemented the sheet method, the completion didn't say state bool, it said binding bool. And this means that we can basically create a two-way connection to our state variable by binding it to something somewhere else. In the case of the sheet method, this is handled for us. But let's see how we might possibly use a state variable to bind it to a variable on another view. Let's take a look at this modal sheet view. It's very similar to the content view in that there is a button to create a new lucky number, and we'll get to that. And there's a dismiss button on the navigation bar. First, let's return to our content view and change the text view to modal sheet view and test it out. Yes, the modal still works and it's presenting our modal sheet view. What we want to do now is to dismiss the modal by tapping on the dismiss button. And for those of you experienced in SwiftUI development, you'll know about an environment variable called presentation mode that can be used to dismiss modal views. And this is great, but I'm not going to cover environment variables here. Let's assume that the environment variables don't exist, so we have to roll our own method here to use the concept of binding. What I'd like to do is dismiss this modal by setting the value of our presentModal state variable in content view to false, thus triggering a change of state that would refresh the view, and since the presentModal would be false, the modal will be dismissed. What we need to do is pass this variable into our modal sheet view, but when we do, we need to wrap it in a new property wrapper called binding instead of a state variable. So in the modal sheet view, let's define that property as a binding, and we'll specify it as a Boolean variable called isShowing. Now we can't assign it a default value because its original value will be coming from the content view, and we also can't make it private. This presents an error in our preview builder, but we can solve that by using a constant value for the binding like this. Now that we have our bound value, we can use our action in the dismiss button to change the value to false, and since it's bound to the original value that we have in the content view, it will be refreshed and the sheet will not appear. Back in content view, we get an error because the modal sheet view is expecting an argument and value for isShowing. And we can solve that by using our presentModal value from this view. Notice that it requires the $sign, and because we're within the sheet method closure, we need to use self. We can refresh our canvas and we find it's working as designed. Let's finish up by looking at state and binding by seeing how we can change the lucky number in content view and have it passed and displayed in the modal sheet view, change it there, and have that change reflected back in the content view. This is another example of state and binding. In our modal sheet view, let's change our number variable to a binding and remove the numeric assignment. We'll shortly be updating our content view to pass in the lucky number value from that view. We also need to update our modal sheet preview to include the number argument. Here we can just use a constant of 11. Let's return to content view to fix that error and pass in our number to the modal view. Testing it out, we see that we have successfully passed our number to the modal view, but we still need to fix the new number button action to see if we have two-way binding. Let's add an action in our button that will change that number to a random number between 11 and 20. Testing the preview, we can update the lucky number, present the modal view and change it there, and see that number changed on the content view. We have a two-way binding via property wrappers. We're off to a good start, but the state property wrapper only works if we're binding single property values to views. What if we have a more complex object? Let's create a new file and call the file user. Within that file, we're going to create a new class called user that has two properties, name as a string and lucky number as an int. We'll also create an initializer for these two properties. What we want to do is to be able to change our two views that we have already to use an instance of this class. And we'd like the lucky number property to be updated by our random number generator. And we'd also like the username to be visible on both screens. In order to do this, we need to make our user conform to the observable object protocol. Anything that conforms to the observable object can be used inside SwiftUI and publish announcements when its values are changed so that the views can be refreshed just like when we change the state variable. So what we need to do is conform user to observable object and then specify which of the properties we want to observe. This is done by assigning the @publish property wrapper to those properties. So in our case, that would be the lucky number. When we create our instance of user, we'll assign values to both properties, but only the number will change. So that's the only one property that we will need to decorate with the @published property wrapper. Let's return to our content view and replace the state private var number equals 0 with an instance of our user object. We can't use state anymore, so we need to change it to @observed object. So we'll change it to @observed object var user equals, and then create an instance of user, initializing it with a name of Stuart and a lucky number of 0. Observed object works very similar to the state property wrapper, but the main difference is that we can share it between multiple independent views, which can subscribe and observe changes on that object. And as soon as a change appears, SwiftUI rebuilds all the views bound to this object. This breaks our code, so let's get it working again. Our text view gets updated by the user.luckynumber. The button gets changed to this. And in the presentation of our modal sheet view, our binding becomes the binding of our lucky number property. Notice that the $ prefaces the observed object, and our lucky number is the published property. Also, let's change the navigation bar title to use our name using the string interpolation. Testing this out, we see that it still works. Our lucky number property is the int that is bound to the binding number property in our modal view. Now I want that title to be used in our modal view as well. So instead of passing in and binding just the lucky number, we can bind the entire object. Only one is being published, but that doesn't prevent us from binding the entire object. The binding is no longer an int. It's going to be a user, so we can change our binding to reflect that. But we also need to change @binding to @observed object because it's no longer a value type, but rather a reference type. Remember, user is a class instance. The text view needs to be changed to use user.luckynumber. Similarly, the button needs changing. And now that we have our user in the modal view, we can change our navigation bar title here to use the username. Our preview provider also needs updating so that it will receive a user instance. So we can change that here. We'll return to our content view now and change our second argument of the modal sheet view to use the user and pass in the entire user instance. Sometimes it's easier just to remove and re-enter, letting autocomplete help you out. Testing again, we see that the username is showing as the title. Let's get a lucky number and go to the modal view, and we see that both the number and the name made it through to the modal sheet. We can update the lucky number here, and because it's published, it's reflected in our content view, but we have no way of updating our name because it's not published. I'll leave it up to you to sort that out. Well, we're down to the final SwiftUI property wrapper, and that's the environment object property wrapper. We've seen how state is used to work with state that is local to a single view, and how the observed object lets us pass one object from one view to another so we can share it. Well, environment object takes that one step further. We can place an object into the environment so that any child view can automatically have access to it. SwiftUI's environment object property allows us to create views that rely on shared data, often across an entire SwiftUI app. Think of environment object as a smarter, simpler way of using an observed object on lots of views. Rather than creating data in some view and then passing it down or up the chain to other views, you can create it in view and put it into the environment so that all dependent views have access to it. It's important to note that environment objects must be supplied by ancestor views, and if SwiftUI can't find an environment object of the correct type, you'll get a crash. And we'll see that. This applies for previews too, so be careful. Let's change the text view in the navigation bar to a navigation link with a destination that will present our nav destination view. Let's test this out. Yes, the link pushes the nav destination view onto the stack. And this view is very similar to other views. It's not been fully fleshed out yet because we want to demonstrate the use of the environment object. As I mentioned, an environment object gets supplied by its ancestor view. So if we set up an environment object for this view, it will have to get passed from an ancestor, which is the content view, because this one is being pushed onto the navigation stack by the navigation link. So let's assume we're going to do that, and let's proceed. We can create an environment object just like an observed object. So in the nav destination view, we'll create a user variable and give it the environment object property wrapper. As with the modal view, we can now update our text view to use our user.luckynumber. And for the button action, let's assign that same value a range of integers from 21 to 30. Next, in the navigation bar, we can use the name. Remember, I said our view relies on our environment object being present, so it's important that you also update the preview code and provide some example setting to use. So we can do this by modifying our preview with an environment object that is bound to an instance of user. It builds fine, but let's run this in the simulator and try to navigate to this view now. If you've been following along, you'll probably realize that there's something wrong. Indeed, there is. When I navigate to this view, the app crashes with thread, fatal error, no observable object of type user found. This is what you'd expect. Environment object gets supplied by its ancestor view, and we've not done that. When we use the modal, we pass the value on from the observed object. When we created this environment object, we didn't pass in a value in our navigation link. We need to change the observed object to environment object, but we can't initialize our user instance here anymore. The user environment object must be provided from some outside entity rather than being created in the current view or specifically passed in. So how do we do this? First, let's prefix our preview by modifying with an environment object bound to a user instance. That way our canvas won't crash. Notice how I added that environment object in the preview? Well, we can do the same thing one level up. And that one level up is the scene delegate. we need to go back to the scene delegate and create our user instance there, and then assign it to the content view as an environment object. So here we can create a var user, and then we can initialize it here with our name and our lucky number. And then in the method where the scene gets attached to the window, naming the root view as content view, we can assign this object as an environment object on the content view. When we run the app now, it seems to work just fine. Our content view gets our instance of user and changes the navigation bar title and sets the value. We can go next and see that the values are there too. If we update our lucky number, it works. There is one issue though. In our modal view, we're using an observed object, and when we should be using an environment object. So let's go back and change it to environment object and update the preview provider as we did before. Now, because it's an environment object, we no longer need to pass our user instance into the modal sheet view from our content view. So we can update the sheet method by removing the user argument from the modal sheet view. I'm going to run this one more time in the simulator because I know something's wrong. When we try to go to the modal sheet view, it crashes. Well, why would that be? Why do I get that error? Well, a modal view is not in the content view's hierarchy, so it has no idea what the environment object is. It's not pushed onto a stack like a navigation view. So for modal views or sheets, we need to add the environment object modifier to the view as it gets presented, like this. And this should look pretty familiar because it's exactly the same way how we added it to the content view in the scene delegate and to our previews. The only difference here is that we add self because we're within a closure. Well, there you have it. It's working. A complete walkthrough of the different ways to pass data back and forth between views, causing state changes and refreshing of the UI to reflect these changes. This is the declarative way of doing things in SwiftUI. I hope you found this video useful. If so, please give it a thumbs up below and subscribe to my channel. If I get enough positive feedback, I'll continue to build out similar tutorials for Swift developers who have left the starting gate but still need to add to their toolbox. You can check out my YouTube channel to see what other videos I've created. Visit my website to see my iOS app portfolio of apps currently on the App Store. And check out my GitHub repository to see what else I'm up to. Thanks for watching. I'm most active on Twitter, so follow me there for notifications of other Swift-related things that I'm up to.